design principle, single responsibility, and then command design pattern. So this is what we are we are discussing. Now, if we see technology, there is a rush for finding independent components. Means relationship is very good, but it doesn't work in programming. So programming work in a fashion that we should have things that are independent to each other. If I have five items and all five items are depend on each other, then the productivity would not be very nice. Means I have five kind of people contributing to the work and or five labors they are contributing to the work and they are related to each other. They will keep talking only means the productivity will not be good. So if five are independent to each other, they don't know each other, then certainly productivity will be high. Like that, if we take help of any, if I am working in a technology and I am taking help of another technology, both should be unrelated to it. So it sums up more. That is the concept. Now, if we see the design principle and design pattern, anyway, they are not related to each other. And designing itself, under which design principle and design pattern comes, they are not related to any technology. If I am working in artificial intelligence, machine learning, or I am doing networking programming, I am doing 3D OpenGL graphics programming. Everywhere I can include designing as it is unrelated. Okay, there is no collinearity. So it is when things are unrelated, then if they come in they will contribute maximum. Now if you see the design principle, all five solid design principles are unrelated to each other, but still we will see that what is the idea behind the things, like single responsibility, where we divide the class into separate classes, separate concrete classes. As far as there are inside the class, if you find there are many reasons to change. If there are n reasons to change, n different classes should be formed. But if you see the interface segregation, then same thing is there. In class, there are many roles. So in a class, we find many roles. There are two things, like one is called client component and one is called service component. Service component which provide the service, and in the service component, if you see that there are many roles, we see, we don't say many reason to change, but if we see many roles, then better all the roles should be segregated as interface. Just see the difference there. All the reason to change comes as concrete classes where all the roles what we see independent role, they would be formed as interface, and service component can realize all the interface in one go, whereas client component which depends upon the service component, now it depends upon the separate interface. So client interface, that will talk, we should not be forced to depend upon a method which it is not dependent upon. So that is the basic concept of interface segregation. So here interfaces are different, and we can realize in one client, one service component. But in single responsibility, the implementation itself is different. So now we'll see now. So if single responsibility is kind of a concept, then its realization is kind of where it will happen. So that is in design pattern. We are seeing the command design pattern. So one example we have taken already example of printer class, where printer class become printer interface, and it has two concrete class. What is the base of the single responsibility, like communicate and print. So now the client can have communicate and print, since they are now comes under command design pattern. So they can be kind of bundled in a batch mode in a list of inside a list of interface pointer, and then someone can say execute. Okay, There can be other example as far as command design pattern and single responsibility is concerned, like robot. A robot is a class which has four methods. Okay, forward, backward, left, and right. If someone calls left, it moves left. If someone calls forward, it moves forward. So there are four reasons to change. Means left has different thing altogether. And if someone say right, all four are orthogonal. Left, right, forward, and behind or backward. Okay, so can we have four responsibility on the robot? So one way is that robot itself will make as interface class, and now we'll have four robot class as implementation. So four methods as per the command design pattern. So four methods left, right, forward, and backward would get responsibility, would get status of class. So four different implemented class is now left, right, forward, and backward. So all four would derive from the robot, or robot forward, robot backward, robot left, and robot right. So they derive from the robot. Now we have four implemented class, four concrete class, which follow the interface of the robot. Now robot, instead of having left right or something, it may have left right and forward whatever, but it provides a new function that is a kind of a template method that is execute, that will be realized by the all the four concrete classes. Execute. Now, kind of someone can create a list of all the list of robot pointer, and in the robot pointer list, he can push the objects like robot left, robot right, whatever it comes as per the need in the execution. Now, since all four robots are robot movement as an object, okay, they are and an object and it follows single responsibility. All four follow single responsibility. One would move left, one would move right, and something like that. Now, someone can just say in the list in a kind of whenever it wants, okay, then he can just iterate through the list, and he can say execute, execute, execute. Okay, so in the iteration of the list. Now, whatever robot instance comes into the picture, if it is left, 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 left 20 times, then he can just say execute, execute, and the robot left class inside the execute, it would call the base, it would call the implementation of the left. So either he can call the base class left or whatever, doesn't matter. But it has execute generic function. So everywhere execute function is there. And all the robot objects which has got the class status from the function status, they can be executed only through execute. So just keep calling execute irrespective of the class, and robot would move. This is one way. This is one way of implementing single responsibility design principle through command design. Other can be robot class, just leave it as it is. So robot has four functions, leave it as it is. And there can be a class called command. Command is an interface and it has a virtual method execute. Now there are four concrete classes that derives from the command interface, that they realize the command interface. Okay, so command left, command right, command forward, and command backward. Same thing. Now the command interface class would keep the robot pointer, and then someone should put the command pointer in the list. Command class keeps the robot pointer, and someone the client call. So client implementation would call the command point. You would keep the command pointer. Command pointer keeps robot pointer, and someone would make a linked list of or list of command point. And in the actual object that would fill the list is the command derived class. So those follow single responsibility. and command left, command right, command forward, and command backward. All four are instantiated and pushed in the list in a implementation way, whatever is required. If someone requires 50 times, it should move forward, and then 10 times it should go left. That's how he would push the objects inside the list and keep calling execute. Both way. Either you derive the robot itself, or you subclass the robot itself, or leave the robot as it is and you have new class called command and subclass the command. And following the single responsibility for all the four methods in the robot, it gets a status of separate classes. They would be derived now, and they would be pushed in a list which is of type command point. List of command pointer. Keep calling execute. And inside the execute, since it has robot pointer inside the command class, so it will call those methods left, right, forward, and backward as per command left, right, command forward, and command backward instantiation realization of the command point. So, orthogonal, you are genius. Means if I am not dependent upon anyone and if I do my work, my intrinsic characteristic is high as per the flyweight design pattern, I can be fit anywhere. So, designing is something that is orthogonal to any of the programming concept. Designing fits in C, designing fits in C++ programming, designing fits in OpenGL, designing fits in networking, designing fits in machine learning, designing fits in Python, designing fits in artificial intelligence, designing fits in deep learning. Whereas in designing, designing principle, design patterns are orthogonal to each other. And inside any design patterns, any design principle fits in and adds as maximum as possible. All design, solid design principles are orthogonal to each other, whereas all 23 design patterns are orthogonal. This is the actual design.